Oh yeah, so welcome to block day 2 or block day 1, asynchronous work. Okay, there are actually many different normal distributions. Each is dependent upon only two parameters, the mean and the standard deviation. So where's the mean and how much is the standard deviation? Similarly between all normal distributions, the graph is bell-shaped and symmetric about the mean. So symmetric, left and right. 68% of the data lies within -1 and 1 standard deviation, below and above the mean. 95, just like we were saying before, the empirical. Let's go on. Differences between the normal distributions, the means can be different. So it could be at like 10 hours or 20 hours for battery life. The standard deviations could be different. Well, that's good. It was like 5, it was like half an hour for the standard deviation. The other one was 0.5 an hour, or 0.4 of an hour, 0.4 of an hour, 0.4 of an hour of a previous activity we had. So it's symmetric about the y-axis, okay, left and right, concave downward, so concave downward, and then upward everywhere else. Asymptotic to the x-axis from above. Okay, so that means it's not going to touch. It's going to get really, really, really close to that x-axis, left and right line, but it's not going to touch it. So this is the standard deviation is 0 right here. And standard deviation is always going to be like 1. It's going to be 1, 1, 1, or -1, down 1. And the area under the curve is equal to 1 square unit. So everything underneath this curve is equal to 1. So area equals 1 square unit. So the total area under the standard normal curve is 1 square unit. This corresponds to the sum of all the relative frequencies of the histogram of a normal distribution set of data. So everything under here is 1 square unit. So if I say, hey, how much is above it? That'd be 0.5 square units. How much below it? 0.5 square units. Okay, what is the area under the curve for the standard normal distribution between 2 deviations below the mean and 1 standard deviation above the mean? Okay, so let's quickly draw our little graph. So we know that's 0. We know they want to go 2 below, and they want to go 1 above. Well, I know that's going to be a couple things. So I'm going to add between here and here, and from here to here. Give me a second to get those numbers in 3, 2, 1. All right, so guys, there's 2 different ways we could have solved this. One, we could have added this value and this value. So 0.135 and 0.68. Or we could have added from 2 to 0 and from 0 to 1 standard deviation above. In either case, let's write it out. 0.475 plus 0.34 would be 0.815 square units. So let's type this out. The area under the curve between 2 standard deviations below the mean and 1 standard deviation above the mean is approximately 0.815 square units. Now you might be thinking, Mr. Phillips, you just said that and you wrote it right there. Well, sentence questions mean sentence answers. All right, let's go on. How is the area under the curve of standard normal distribution related to the percent of data or data within a specific interval of the normal curve? Well, what is this asking? Well, it's asking what about percentages? Well, guess what? 100% is like 1. So, the same calculations are required for both types of questions. Both answers, get out of here, Mr. Schultz. We're going to move you up here. So both answers represent a part of one whole. One is the total area under the curve, and the other is the total of the frequency distributions. So just make one is the percentages, and the other one is going to be like, how much of one, which is the percentages. All right, let's continue onward to block day 2. Bye, everybody. Have a good one.